Hello, grade 8 learner! Welcome to another video lesson in mathematics. In this video lesson, we will be discussing about how to add rational algebraic expressions with common denominators. It's another great day to learn, so prepare your pen, paper, and module as you start watching and learning from this video lesson. Happy learning! This lesson is based on the K-12 curriculum learning competency. The learner performs operations on rational algebraic expressions. By the end of this lesson, you, the learner, should be able to follow the steps in adding rational algebraic expressions with common denominators and to apply appropriate factoring techniques in adding rational algebraic expressions with common denominators. Just like the previous lessons we've had on rational algebraic expressions, we begin the lesson with a review on how to add fractions. Given the fractions 2/7 and 5/7, we add them by first checking if the fractions have common denominators. Both fractions have 7 as a denominator, so we continue by adding the numerators, then copying the common denominator. Thus, we add 2 and 5 to get 7/7, which, when simplified, results in 1. Let's take a look at another example. When we add -7/4 with 5/4, we follow the same process since they have common denominators. We add the numerators and copy the common denominator, which leads us to the result, which is -2/4. But we have to simplify our final answer, which means we have to find and cancel out common factors between the numerator and denominator of our result. We see that the common factor of -2 and 4 is 2, so we cancel that out and get -1/2 as our final answer. Take note of this process as we discuss further. To add rational algebraic expressions, we use the formula A over C plus B over C is equal to A plus B over C, where A, B, and C represent polynomial expressions, and that the denominator C is not equal to 0. This means we follow the same process as adding fractions. Take, for example, 8/5p plus 2/5p. We see that both of the expressions have the same denominator. Therefore, we can simply add 8 and 2 and copy the common denominator 5p. Doing that will give us 10/5p. However, this expression can be simplified. So we do that by factoring out and canceling 5, which is the common factor between the numerator and denominator, leaving 2/p as our final answer. To study further how to add rational algebraic expressions, let's look at more examples. Let us solve for the sum of a minus b over 8b and 6a minus 3b over 8b. So our first step is to check if the rational algebraic expressions have common denominators. We do this because the formula we have just discussed cannot be applied to RAEs with dissimilar denominators. In our example, however, we see that both RAEs being added have the same denominator. Thus, we can move to the next step. Because the RAEs that we are adding have common denominators, we can now add their numerators and copy the denominator. Thus, we combine similar terms that we see, like a plus 6a and negative b minus negative 3b. Now that we have combined similar terms, we now add them properly. Thus, we get the result, which is 7a plus negative 4b over 8b. As the final step, we are going to simplify the expression as needed. But since the numerator 7a plus negative 4b and the denominator 8b do not have any common terms, we just rewrite the double signs to simply have 7a minus 4b over 8b as our final answer. Let's see another example. This time, we deal with more polynomials as we add negative 4m plus 10 over 2m squared plus m minus 3 and negative 7 plus 6m over 2m squared plus m minus 3. We follow the steps by first checking that the RAEs have similar denominators. Looking at the two RAEs we have similar RAEs, or RAEs with common denominators. So we proceed to our next step. We then add the numerators and copy the similar denominator. In this example, we add negative 4m plus 10 to negative 7 plus 6m, and then we copy the denominator. Combining the similar terms in our numerator, we have negative 4m plus 6m in one group and 10 minus 7 in another. After combining similar terms, we add negative 4m and 6m and 10 minus 7 to get the numerator 2m plus 3, with of course the same denominator 2m squared plus m minus 3. But we have to simplify our final answers. Thus, we check the factored forms of the numerator and the denominator for any common factor that we can cancel. Here, we see that 2m plus 3 is present in both numerator and denominator, so we cancel those similar factors out. After canceling out the common factors, we check what is left in our expression. In the numerator, we canceled out 2m plus 3, which leaves the constant factor 1 in the numerator, while m minus 1 remains in the denominator. Therefore, our final answer is 1 over m minus 1. Good job for following the lesson! If there are some things which are still not clear to you, just replay this video, read your module, or ask help from your teacher to improve your learning. Before we end this lesson, try to solve the following problem. Solve for the sums of the RAEs 3x squared minus x over 2x plus 1 and x squared minus 2x over 2x plus 1. Remember to follow carefully the steps we have just discussed. Pause this video and solve before we reveal the answer. Done? If your answer is 4x squared minus 3x over 2x plus 1, good job! You've got the correct answer. If you didn't, check out the solution to see where you went wrong. Congratulations for finishing this video lesson. We hope that we have made things clearer for you. Vernon Howard said it best when he said, "Always walk through life as if you have something to learn, and you will." So keep on learning, dear learner, and we'll see you again in our next video module.